A preamp takes a microphone's electrical signal and boosts it up to line level. Preamps change the microphone signal before it travels down a channel rack. There are 3 different types of preamps: transformers, transistors, and tubes. High-end preamps allow for better quality recordings. Once a signal reaches line level, it should be processed through an EQ and a compressor. This signal travels into a DAW, into a mixing console, and into a final file. Audio tracks can be sent through an auxiliary track for time-based effects like reverb and delay. Don't directly apply reverb to an audio track. There aren't any standard mic choices for vocal recordings. The mic choice is determined by the vocalist's dynamic range. Be sure to use a high-quality preamp. Vocalists define a band's character. Place the vocalist up to 12 inches away from the microphone to avoid picking up too much sibilance. Imperfections in pitch can give a vocal character. Organize vocal tracks with their effects in the mix window. Mixing normally combines vocals with drums, instruments, and chords to communicate an idea. Don't monitor too loud and don't fluctuate monitoring volume. Record good levels from the start to ensure that the mix is effective. Phase relationships affect the sound of other tracks within a mix. Depending on the type of kick or sample, add high-end sizzle to the snare top. Roll off low-end and overhead and room mics. Use a high-pass filter to allocate space in the mic for basses. Short reverb should be used in songs with faster tempos and vice versa. To boost loudness in industry or radio standards, use a peak limiter on the master track. DigiDesign's version of this is called Maxim. Lower the ceiling to -0.1 decibels and lower the threshold to reach a desired non-clipping volume. In order to assure that a mix sounds great outside your studio monitoring system, be aware of the acoustics of the studio. The room dramatically affects what is heard through your reference monitors. A poorly treated room can remove up to 15 decibels of low end before it reaches your ears via phasing. Whenever a room contains gear that emits noise, a noise floor is created which negatively affects perceived low end in a room. Isolate noisy equipment from a recording space. Install weather strips into window and door spaces to reduce outside noise from entering a recording space. Room modes are directly correlated to the design of a control room. Size, shape, and materials in a room affect the travel of sound waves capable of cutting up to 20 decibels of a frequency. If a speaker is placed in the corner, low-end response will either be dramatically increased or diminished if not properly treated with a bass trap. Bass absorbers can effectively reduce standing waves in a control room. Depending on the material, sound waves are either reflected, absorbed, diffused, or transmitted through. Early reflections occur when reflected sound is perceived in conjunction with direct sound waves, making way for possible phase issues which affect perception. To treat this, install absorption panels at angles of reflection and properly position reference monitors to directly reach the engineer's ears. Angle the wall directly opposite from reference monitors to break up the main axial reflection waves. Place speakers a third of the way into the room to avoid low frequency buildup behind them. Don't overtreat the sidewalls. Doing so will diminish character from the control room and undesirably affect perception.